Hello, in this lecture we'll find out the area of the orange shape. In the drawing we have square ABCD. One side of square ABCD equals to 10 units. Inside square ABCD we have two semicircles that intersect with each other. Here this is semicircle APQ that intersects with semicircle CPD, and they create the blue lens that is the common area of the two semicircles. In addition, we have the quarter circle ABQD intersects with semicircle CPQ, and they create the big lens. This is the big lens, and our mission is to find out the area of this orange shape. So actually the area of the orange shape equals to the area of the big lens minus the area of the blue lens. So we will find out the area of the big lens, and then we will find out the area of the blue lens, and we will subtract the two areas from each other, and this will be the area of the orange shape DQP. Okay, so I write it down. The general solution of the problem is to subtract the area of the big lens or to find out the area of the big lens and subtract from it the area of the blue lens. Okay, it will be equal to area of the orange shape. I repeat again. The general idea to find out the area of the green shape, the area of the green shape equals to the area of the big lens minus the area of the blue lens. Okay, when we subtract the area of this blue lens from the area of this big lens, we get the area of this orange shape DPQ. Okay, and we will actually solve this problem in two different methods. In the first method, we will find out a formula for the area of any lens, and then we will use this general formula in order to find out the area of the big lens. Then we find out the area of the blue lens according to the formula, and the subtraction of the two areas from each other will give us the area of this orange shape DPQ. Okay, this will be the first method. We'll start with the first method, and in the first method we'll find out a general formula for the area of any lens. So here we have, but before that I will remind you what is the area of a sector. Here this sector AOB, the area of this sector AOB equals to the area of the circle that is radius is r, so it is pi r squared, that is the area of this circle, times theta over 2 pi. Actually, the ratio theta over 2 pi will give us the amount of percentage. Actually, here we have this sector. This is sector. This is the green sector, and the area of this green sector will be equal to pi r squared. Pi r squared is the area of the circle, and we'll multiply the area of the circle by the amount of percentage that this sector occupies from all the circle. When we multiply the amount of percentage that this sector occupies from all the circle, we get exactly the area of this sector. Okay, so pi theta over 2 pi, 2 pi radians is 360 degrees, so theta over 2 pi will give us the how many percentage this sector occupies out of these all circles, out of the all circle, and then when we multiply the amount of percentage that this sector occupies out of this whole circle, when we multiply it by the area of this circle, we will get exactly the area of this sector. So theta over 2 pi will give us the percentage times the area of the circle, that is pi r squared, will give us exactly the area of this green sector that you see in the drawing. So this is the formula for the area of any sector. In the next step, I will explain to you what is the area of this circular segment AB. The area of this circular segment AB, it is very easy to see from the drawing that the area of this green shape, that is circular segment AB, the area of this circular segment equals to the area of sector AOB. This is the area of sector AOB minus the area of triangle AOB. Okay, so the area of sector AOB minus the area of triangle AOB will give us exactly the area of this green shape, that is the area of circular segment AB. Okay, so we'll calculate the area of sector AOB according to this formula. We'll find out the area of this triangle. That is very simple. And then we'll subtract from the area of sector AOB the area of triangle AOB. In this way, we'll get the area of the green shape, that is the area of the circular segment AB, the green shape. Okay, so we'll use those two formulas a lot during the two methods. Therefore, it is very important that you will understand the two formulas. I repeat again that the area of this circular segment AB, the green shape, equals to the area of sector AOB minus the area of triangle AOB, while the area of this sector in the green color, it is equals to pi r squared. Here r is the radius of this circle, So pi r square is the area of this circle times theta over 2 pi, that give us the ratio that give us the amount of percentage that this sector occupies out of this whole circle. So the amount of percentage that this sector occupies from this circle times the area of the circle will give us exactly the area of this sector in this red green color. Okay, so those two equations, those two formulas are very important because we use them a lot during the two methods that I will present to you. So, as I've already mentioned here we will find out general formula for the area of any length. And then we will use this general formula in order to find out the area of the blue lens. We will use the general formula in order to find out the area of this big lens, and when we will subtract the area of the big lens minus the area of the blue lens will give us exactly the area of the orange shape DQP. Okay, very simple. So we start with the first method. Actually, what is a lens? A lens is the common area that is created by the intersection of two circles or semicircles with each other. What is the common area of those two semicircles? They are actually perpendicular to each other. The common area is this shape, and this is the length that we want to find out the area of this length. Okay? So we will draw here the this point O is defined as the center of this semicircle, and here this point will be defined as point M. So point O is the center of this semicircle, point M is the point of the semicircle itself, therefore OM is the radius of this semicircle. We'll define the radius of this semicircle as A. It is equal to A units in its length. We'll define this point as point N. Point N is the point of tangency of tangent LN with this semicircle. Okay, it is point of tendency point O is the center of this semicircle. Point N is the point on this semicircle itself. That is to say, it is line segment ON is the radius of this semicircle, and the radius of this semicircle equals to A units according to our definition. So here we have the radius ON. It is drawn to the point of tendency. That is to say, it is drawn to point N. That is the point of tendency of tangent LC with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent LN will be perpendicular to the radius NO. So if LN is perpendicular to NO, it means that this angle equals to 90 degrees. Okay? Point L is the center of this semicircle. Point N is the point on this semicircle itself. this is exactly the definition of a radius. That is to say, NL, line segment NL, is the radius of this semicircle. We will define the radius of this semicircle as B. So NL equals to B. Here point L is the center of this semicircle. Point M is the point of this semicircle itself. That is to say, LM is the radius of this semicircle that is equal to B units according to our definition. Okay? So here we have the radius OM that is equal to A, that is drawn to the point of tendency. M is the point of tendency. Of tangent LM, that is also the radius, with this semicircle. So we have here the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tangency of tangent LM with this semicircle, and whenever we have a radius that is drawn to the point of tendency, then tangent LM will be perpendicular to the radius MO. So if LM is perpendicular to MO, it means that this angle equals to 90 degrees. Okay? In the next step, we'll join points M and N together by a straight line. And we'll join points L and O together by a straight line. Actually, here, line segment NM divides this length into two parts. We will find out the area of each part, and we will add the two areas together, and this will be the area of this length. Again, a length is the common area that was created by the intersection of those two semicircles with each other. Again, here you can see that the area that belongs to both semicircles is this area, and this area is defined as a length. And we want to find out the area of this length. Okay, so the area of this length will be equal to the area of this, the green circular segment NM, plus the area of the lower circular segment. Okay, so in the first step, we'll find out the area of the upper circular segment, the green circular segment, and then we'll find out the area of the lower circular segment. Okay, so what is the area of this circular segment NM? The area of circular segment NM the area of the green circular segment NM will be equal to the area of sector NOM, this sector, this is sector NOM minus the area of triangle NOM, minus the area of this triangle, triangle NOM. Okay? Okay, minus the area of this triangle, triangle NOM. It is very easy to see that when you subtract the area of triangle NOM for the area of sector NOM, you will get exactly the area of circular segment NM, the upper circular segment NM. Okay? So, in order to find out the area of sector, this is sector NOM. In order to find out the area of sector NOM, we have to find out the angle that is between his legs, this angle. So, what is the size of angle NOM? That is the angle between the legs of sector NOM. We will define this angle as theta. Actually, those two triangles, triangle LNO and triangle OML, they can go into each other. Why they can go into each other? Because NO equals to OM. Both those two sides are equal to A, therefore they are equal to each other. In addition, both those two sides, NL and LM, they are both equal to B, therefore they are equal to each other. And finally, side OL is a common side that belongs to both triangles, so side OL equals to itself. So actually we found out that those two right triangles can go into each other according to side rule. And from the fact that those two right triangles can go into each other, we conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if those two angles are equal to each other, and this angle NON equals to theta, then this angle NON must be also equal to theta because of the fact that those two angles are equal to each other. So we actually found out that the angle between the legs of sector NOM, this sector, is equal to theta plus theta, this is 2 theta. So we can write here that the angle between the two legs of sector NOM, it is equal to 2 theta. So what is the area of sector NOM? The area of sector NOM equals to the area of the circle. The area of a circle is pi r square, and here r, the radius, equals to a, so it is pi a square. That is the area of the circle times the ratio between this angle, that is 2 theta, over 2 pi radians, that is equal to 360 degrees in terms of degrees. Okay? The ratio will give us the amount of percentage of that this sector occupies out of the whole circle, and then when you multiply the amount of percentage that this sector occupies out of the whole circle by the area of the circle, you will get exactly the area of this sector. Okay? So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So in conclusion, what is left here after we cancel those two variables? What is left is theta times a squared. So the area of this sector NOM, it is equals to theta times a squared. Okay? And we also have to subtract from the area of sector NOM the area of triangle NOM, but we'll do it later. This is triangle NOM. Actually, we'll combine the two triangles together and we'll find out the area of the two triangles. Actually, in the first method, we don't have to calculate the area of the triangles at all. So first, we will leave this triangle as it is, and we will calculate the area of the lower circular segment. The area of the lower circular segment, the orange circular segment, what is the area of the lower circular segment or the orange circular segment? It will be equal to the area of sector NLM, this sector, minus the area of triangle NLM. Okay? So it will be equal to, so the area of the orange circular segment NM it is equal to the area of sector M and L, this sector. So I'll draw it here. Sector L and M. This is sector NLM. So the area of the orange circular segment MN equals to the area of, actually here it is, of course, I forgot this. This is exactly the area, the sector, this is sector NLM. Okay, this is sector NLM, and we have to subtract from sector NLM, from the area of sector NLM, the area of triangle NLM. So it is minus the area of triangle NLM. I repeat again, the area of circular segment M equals to the area of sector NLM minus the area of triangle NLM. It is very easy to see from the drawing that if you subtract the area of triangle NLM from the area of sector NLM, you will get exactly the area of the orange circular segment, this circular segment NM. Okay? So we'll find out the area of sector NLM. In order to find out the area of sector NLM, we have to find out the size of angle NLM, the size between its legs. Okay, the size of the angle between its legs and L and LM. So actually, the size of angle NLM. So what is the size of angle NLM? We know that this angle equals to theta. This angle equals to 90 degrees, that is pi over 2 in terms of radians. So this angle must be equal to 90 degrees minus theta, or in terms of radians, it must be equal to pi over 2 minus theta. And here, those two triangles can go into each other, as I already mentioned, according to side rule. So therefore those two angles must be also equal to each other. So if this angle equals to pi over 2 minus theta, then this angle must be also equal to pi over 2 minus theta. Okay? And you can see that it is equal to pi over 2 minus theta, because this angle equals to theta, this angle equals to 90 degrees, so this angle must be equal to pi over 2 minus theta in order to complete the sum of the angles in this right angle, 280 degrees. This angle anyway must be equal to pi over 2 minus theta. Okay? So in conclusion, the size of angle N and M will be equal to the sum of those two angles. That is to say, it will be equal to angle pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, found out that the area that the size of angle NLM, the size of this angle, that is angle NLM, equals to pi minus 2 theta. Okay, is equal to pi minus 2 theta. So here we found out that angle NLM equals to pi minus 2 theta, that is actually in terms of radians, of course. In terms of degrees, you can say that this angle equals to 180 degrees minus 2 theta. Okay, so what is the area of sector NLM? The area of sector NLM equals to the area of the circle, that is pi r squared, and r, the radius, equals to b, so it is pi b squared, that is the area of the circle, the whole circle, times the ratio between the angle that is between the legs of sector NLM over 360 degrees, or in terms of radians, it is 2 pi. Okay, it is pi minus 2 theta, that is the angle between the legs of sector NLM, over 2 pi radians, that is 360 degrees in terms of degrees. Okay, so here we have pi in the numerator, we have pi in the denominator, so pi will get cancelled. In the next step, we will open the brackets here. So we have b squared times pi is pi b squared over 2, and b squared times minus 2 theta is minus b squared times 2 theta over 2. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. So in conclusion, the area of sector NLM, this sector, it is equal to pi b squared over 2 minus theta b squared. So this is the area of sector NLM, and we have to subtract from the area of sector NLM the area of triangle NLM, the area of triangle NLM. Okay. So here we also have to subtract from the area of sector NOM the area of triangle NOM. So in conclusion, we have to subtract. So if we add the two circular segments together, we will get the area of the length that we are looking for. This is circular segment, the upper circular segment NM. So if we add the two circular segments together, we get the area of the length, the area of this length. Okay, so the area of the length, that could be any length, is equal to the area of the upper circular segment NM, the green circular segment, plus the area of the lower circular segment, the orange circular segment NM. That is to say, it will be equal to the area of the upper circular segment NM equals to the area of sector NOM that is sector NOM minus the area of triangle NOM plus the area of the lower orange circular segment NM, and the area of the lower circular segment NM equals to the area of sector NLM. This is sector NLM minus the area of triangle NLM. Okay, minus the area of triangle n in length. So in conclusion, the area of this length equals to the sum of the areas of those two sectors minus the sum of the areas of those two triangles. Okay. So the area of sector NOM equals to theta times A squared plus the area of sector NLM, the area of sector NLM. In total, it is equal to pi b squared over 2 minus theta b squared. So those are the sum of the areas of the two sectors, and we have to subtract from the area of the two sectors the sum of the areas of the two triangles. So it is minus the area of those two triangles, triangle NOM, and this is triangle NOM, plus the area of triangle NLM. Okay, we've already found out the area of the two sectors. Now the only thing that is left to do is to find the area of the two triangles and subtract them, add them together and subtract them from the area of the two sectors, the sum of the areas of the two sectors. Okay, so here, in order to find out the area of the two triangles, we'll join them together. By joining the two triangles together, we created here quadrilateral NLOM. Okay. And N equals to B, LM equals to B, and O equals to A, and OM equals to A. Here, this angle equals to 90 degrees, angle ONL, and this angle OML also equals to 90 degrees. Now we'll join points O and L together by a straight line. By joining points O and L together by a straight line, we created two right triangles. We created the right triangle, triangle O and L, the right green triangle, triangle O and L, and we also created the right orange triangle, triangle OLM. Now it is very easy to find out the area of each right triangle. The area of the green right triangle equals to the base of the triangle, that is B, times the height to the base, that is A, over 2. The area of triangle, the green right triangle, equals to B times A over 2, while the area of the orange right triangle LOM, it will be equal to the base of the triangle that is A times the height of the base that is B over 2. So the sum of the areas of the two triangles equals to BA plus AB over 2. BA plus AB is 2 times AB divided by 2. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. In conclusion, we found out that the sum of the areas of the two triangles, it is equal to A times B. A is the radius of this semicircle, while B is the radius of this semicircle. So for that reason, that A and B are the radii of the semicircles, we don't have at all to find out the area of the two right triangles. We just have to subtract AB from the sum of the areas of the two sectors. In this way, we will find out. So here, the area of those two triangles equals to A times B. So we subtract AB from the sum of the areas of the two sectors, and this way we'll get the area of this length. I repeat again that for that reason we don't have to find out the areas of the triangles, but we just subtract A times B from the sum of the areas of the two sectors, and in this way we get the area of a sector, this sector that could be any sector. Okay? So the area of sector NM the area of the sector that could be any sector equals to theta A square plus pi B square over 2 minus theta B square minus AB. That's all. That is the area of the sector that could be any sector. Okay, so in the next step, we take theta as a common factor from this expression and from this expression. So theta is a common factor. Inside, what is left from this expression after we took from it theta as a common factor, what is left is actually A squared. And what is left from this expression after we took from it theta as a common factor, what is left is actually minus B squared. And we have also to add pi B squared over 2. And we have to subtract AB, that is the sum of the areas of the two right triangles. Okay, so that is the area of a length that could be any length. But here we want to have only one variable that is missing, that is the radii of the two shapes. And here we have theta. We want to eliminate theta from this equation. So in order to eliminate theta, I will draw the right triangle LNO that contains theta. So this is the right triangle NOL that contains theta. In this triangle, the right triangle NOL, tangent theta equals to NL over NO. NL over NO. NL equals to B, NO equals to A. So in conclusion, we found out that tangent theta equals to B over A. Tangent theta equals to B over A. But the problem is that we don't want the value of tangent theta, but we want the value of theta itself. In order to get the value of theta itself, we will operate the opposite function of tangents on the result, that is B over A. In this way, we will get the value of theta itself. So here actually theta itself equals to, when we operate the opposite function of tangents, is tangents minus 1 on the result, that is B over A, we will get the value of theta itself. This is B over A. In conclusion, we found out that theta equals to tangents minus 1 of B over A. So we can substitute theta in this formula by tangents minus 1 of B over A. We'll do it now, and we'll get that the general formula that for the area of any length will be equal to theta, and theta is tangents minus 1 of B over A times A squared minus B squared plus pi B squared over 2 minus AB. So we found out general formula for the area of any length. This is the general formula for the area of any length. Is equals to tangent theta of B over A times A squared minus B squared plus pi B squared over 2 minus AB. The only missing variable here are variables here are A and B, that the radii, the only missing variable here is the radii of the two shapes. It could be two semicircles that intersect with each other, or two quarter circle, or a quarter circle with a semicircle, or a quarter circle with a circle. The only thing that we have to know in order to find out the area of the length that was created by the intersection of the two shapes is the radii of the two shapes. In this way, we get the area of the length that was created by the intersection of the two shapes. Okay, I remind you that a lens, this is a lens, and the lens is the common area that was created by the intersection of two shapes. It could be two circles or two semicircles or two quarter circles or quarter circle with a semicircle. Okay? Now we have a formula that we will use it in order to find out the area of the area of this blue lens, and in order to find out the area of the big lens. Okay, so here the area of the big lens, this is the big lens. What is the area of the big lens? Actually, the big lens was created by the intersection of the quarter circle, this is the quarter circle, with this semicircle. The intersection of those two shapes with each other gave us the big lens. So the only thing that we have to know is the radii of those two shapes. The radii of the quarter circle equals to 10 units, as you can see here. So A equals to 10. And B, what is the radius of the semicircle? We know that the diameter of this semicircle equals to 10 units. It is also the same thing is true for the diameter of the other semicircle. Both diameters are equals to 10 units. So if the diameter equals to 10 units, it means that the radius will be equal to half of it. That is to say, it will be equal to 10 over 2, that is 5. So the radius B here will be equal to 5 units. And the radius of the other semicircle will also be equal to 5 units. So now we want to find out the area of the big lens. And we know that the radius of the quarter circle equals to 10 units, A equals to 10, and the radius of the semicircle, that is B, it is equal to 5. So we will put the values of A and B inside this formula, and we will find out the area of the big lens. So, okay, so here we know that A equals to 10 and B equals to 5, so it is tangents minus 1, that is the opposite function of tangents of B over A. B is 5 and A is 10. So 5 over 10 is 1 half. 1 half is 0.5. So it is tangents minus 1. B over A is 0.5 times A squared minus B squared. A is 10, so A squared is 10 squared minus B squared. B is 5, so B squared is 5 squared. Plus pi times B squared. B squared is 5 squared over 2 minus A times B. A is 10 and B is 5. Okay? So in conclusion, we found out that the area of the big lens equals to this expression. Ten squared is 100, while 5 squared is 25. 100 minus 25 is 75. So it is equal to 75 times tangents minus 1 of 0.5 plus 5 squared is 25, 25 over 2 is 12.5, so this expression in total equals to 12.5 pi minus 10 times 5 is minus 50. So in conclusion, we found out that the area of the big lens equals to 75 times tangent minus 1 of 0.5 plus 12 pi minus 50. Okay, in the next step we'll find out the area of the blue lens and we'll subtract the two areas from each other, and this will be the area of the orange shape, as I already mentioned. So I already explained a couple of times. So what is the area of the blue lens? Actually, the blue lens, it is equal to, actually the blue lens this blue lens was created by the intersection of the two semicircles with each other. Okay? And we know that the radius of any semicircle equals to 5 units. So here we find out the area of the blue lens. We know that A equals to B equals to 5 units. So we'll put the values of A and B inside the general formula for the area of any lens, and we find out the area of the blue lens. Okay? Okay, so the area of the blue lens Okay, so the area of the blue lens equals to tangents minus 1 of b over a. B is 5 and a is 5, so 5 over 5 is 1, so it is tangents minus 1 of 1. A is 5 and b is 5, so a squared minus b squared is 5 squared minus 5 squared. That is 0. So this expression it is equal to 0, so I write it anyway. Plus pi b squared plus pi b squared plus pi b squared and pi is 5, so b is 5, so b squared is 5 squared, that is 25. So it is plus 25 pi over 2 minus ab. A is 5 and b is 5, so 5 times 5 is 25. Okay, so in conclusion, I found out that the area of the big lens equals to tangents minus 1 of 0.5. 5 squared minus 5 squared is 0, so this expression equals to 0. And here we have 25 pi over 2, or 25 over 2 is 12.5. So in total this expression equals to 12.5 pi minus 25. So in conclusion, the area of the blue lens equals to 12.5 pi minus 25. Okay, so we subtract the area of the blue lens from the area of the big lens, and this will be the area that we are looking for, that is the area of the orange shape. Okay, so we found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50, and we have to subtract from the area of the big lens the area of the blue lens, and the area of the blue lens it is equal to 12.5 pi minus 25. So we subtract the two areas from each other. We subtract the area of the blue lens from the area of the big lens, and we will get that the area of the orange shape it is equal to the area of the big lens minus the area of the blue lens. Okay, I repeat again, the area of the orange shape equals to the area of the big lens minus the area of the blue lens. And the area of the orange shape will be equal to the area of the big lens is 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50 minus the area of the blue lens is minus 12.5 pi minus 25. It is the area of the blue lens. So the area of the orange shape equals to, here we will open the brackets, it is equal to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 12.5 pi, and minus is plus, so it is minus 25, it is plus 25. So here we have 12.5 pi minus 12.5 pi is 0, so those two expressions will get cancelled. And we have here it is actually here 70, the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50, and 25 minus 50 is minus 25. So in conclusion, the area of the orange shape is equal to 75 times tangents minus 1 of 0.5 minus 25. Okay. Repeat again, the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. And we know that tangents minus 1 of 0.5 equals to 0.46. We have to multiply 0.46 by 75. So here 75 times 0.46 So 75 tangents minus 1 of 0.5 equals to 0.46. So it is 75 times 0.46 minus 25. And 75 times 0.46, it is equals to 34.77 minus 25. So the area of the orange shape equals to 34.77 minus 25. 34.77 minus 25, it is equal to 9.77 square units. Okay, so in conclusion, we found out that the area of the orange shape equals to 9.77 square units. We finished with the first method. So in the next step I will present to you the second method. I repeat again that the area of this orange shape equals to 9.77 square units. Okay. So in the second method, we will calculate the area of the orange shape, and then we'll calculate the area of this blue lens we calculate the area of the big lens, and we subtract the area of the blue lens from the area of the big lens. In this way we get the area of this orange shape dpq. But we will not use the general formula for the area of any lens, but we will directly calculate the area of the big lens and the area of the blue lens, and we will subtract the two areas from each other. In this way we'll get the area of the orange shape. But according to the second method, here we will have to calculate the areas of the triangles that are part of the sectors. Okay? While in the first method, we don't have to calculate the areas of the triangles at all. Here we have to calculate the area of each triangle that is part of the sector in order to find out the area of the circular segment itself. So we'll start to find out the area of this blue shape, and we already found out that the area and the radius of this blue shape was created by the intersection of the two semicircles with each other, and the radius of each semicircle is equal to 5 units. Okay? Actually, we can use the things that we found out in the first method, but here, instead of writing down that the radius of this semicircle is 5 and the radius of the other semicircle, the radius of this semicircle is A and the radius of the other semicircle is B, here the radius of both semicircles will be equal to 5 units. Okay, so A equals to 5 and B equals to 5. Okay, so here we have already found out that this angle, this is the radius of the semicircle, point O, where point M, here A equals to 5 units because the radius of the semicircle equals to 5 units. Here we have ON, A equals to 5 units. Angle ONL equals to 90 degrees. Those two semicircles intersect with each other at 90 degrees. That is to say, the two semicircles are perpendicular to each other. Okay? We have already found out that angle OMM equals to 90 degrees. It is a right angle. Here, line segment NL is the radius of this semicircle that is equal to 5 units. And also line segment LM, it is also the radius of this semicircle that is also equal to 5 units. Point L is the center of this semicircle, and point O is the center of this semicircle. We have already found that this angle equals to theta, and this angle also equals to theta in the first method. And here we divide the blue lens into two equal parts. Here the two parts, that is to say the two circular segments, the upper circular segment and the lower circular segment, they are equal to each other because of the fact that the radii of the two semicircles, they are equal to each other. Therefore, the circular segments must be also equal to each other. So actually, we will find out the area of the upper circular segment, and then we'll multiply it by 2, and in this way we'll find out the area of the blue lens, because the two circular segments are identical, that is to say they have the same areas also. Okay, so here, so our mission is to find out the area of the blue lens. Okay, so the area of the blue lens the area of this blue lens, actually it is not blue here, but in the original drawing it is blue lens. Okay, so call it as a blue lens. So the area of this blue lens equals to the area of circular segment, the green circular segment, times 2. So I write it down that the area of the blue lens equals to 2 times the area of circular segment NM. The area of the upper circular segment times 2 is the area of the blue shape. Okay, so the area of the blue lens equals to 2 times the area of circular segment NM. לא?
היי, שלום, כאן מדבר אמיר, speak in English?
כן. מה זה? לא הבנתי מה עשית. אמרתי לך, אתה צריך להוסיף לי עוד 2 שיעורים. החבילה נגמרת ב-28 לשישי, אז קודם כל אתה צריך להוסיף ליום שישי הזה עוד חצי שעה מ-11 עד 11 וחצי. אחרי זה 128 לשישי, אתה צריך להוסיף עוד 2 שיעורים של שעתיים כל אחד ליום שישי הבא וליום שישי שלאחר מכן. איך הגעת ל3? הרי רכשתי 9, נכון? אז זה אומר שברגע שירד אחד בשביל יום שישי הקרוב, יש עוד 2 שיעורים.
אבל אוקיי, סיימת? אתה רוצה להקשיב?
כן.
השיעורים שלך קבועים מ-9 עד 11.
כן.
אמרתי לך את זה, שלחתי לך הודעה, הם קבועים.
נו.
אין מה לקבוע, מה שכבר קבוע.
מאחרי ה-28 לשישי. נו.
זה נגמר בשעה 11. שאלתי אותך, אתה רוצה להוסיף את 11 עד 11 וחצי? אמרת כן.
כן.
בכל רשום.
לא, אבל אתה לא מבין. תשמע, אני צריך להוסיף חצי שעה רק ליום שישי הבא, זהו. אחרי זה אני רוצה להוסיף 128 לשישי, שעתיים כל שיעור ביום שישי. זאת אומרת, אתה צריך למעשה להוסיף רק חצי שעה ליום שישי הקרוב וזהו. אחרי זה עוד שיעור של שעתיים 128 לשישי ליום שישי שלאחר מכן, ואחרי זה עוד שיעור של שעתיים שבוע לאחר מכן. לא להוסיף שיעורים של חצי שעה, רק ליום שישי הקרוב. פשוט הקטע זה שאני עושה את הוידאו, זה לוקח לי 3 שעות, ולכן החלטתי שהשיעור צריך להיערך 2.5 שעות, אבל אני לא דיברתי על השיעורים שלאחר מכן. אני לא אמרתי להוסיף כל יום שישי חצי שעה לשיעור שלאחר מכן. אני התכוונתי שרק ליום שישי הקרוב, בגלל שההרצאה תיקח לי כ3 שעות, צריך להוסיף חצי שעה, ולאחר מכן צריך להוסיף 128 לשישי, שעתיים. מה?
איך זה אמור אוקיי, אז בוא תראה, אני בטל את השיעורים, נשלח את הקישור של היומן, ותקבע איך שאתה רוצה את השיעורים פשוט.
לא, תבין, רק ליום שישי הקרוב, אני לא יכול, כי אני את היומן, לא. זה מה שהייתה עושה בר כל הזמן בלי בעיה, היא הייתה עושה את זה תוך שנייה. אחרי זה אומרת, קבעתי וזהו. מילה אחת שאת אומרת קבעתי וזהו, לא צריך לעשות שום דבר, היא הייתה עושה את זה צ'יק צ'ק. הנקודה היא שלשיעור הבא, בגלל שהוא לוקח לי הרבה זמן, רציתי להוסיף חצי שעה. ולאחר מכן לא להוסיף חצי שעה לכל שיעור של שעתיים, אלא 128 לשישי לעשות שיעור של שעתיים ביום שישי שלאחר מכן, ועוד שיעור של שעתיים ביום שישי שלאחר מכן. זה הכל. זה מה שהיית עושה בר כל הזמן, בלי שום בעיה. כן, אז כאילו לא צריך, רק ליום שישי הקרוב תוסיף את חצי שעה, בגלל שאני יודע שמראש זה הרצאה שזה ייקח לי הרבה זמן. ולאחר מכן יש 128 לשישי, ליום שישי שלאחר 28 לשישי, שעתיים. אחרי זה ליום שישי שלאחר מכן עוד שעתיים. אז זה יוצא בעצם 2 שיעורים של שעתיים ליום שישי שלאחר 28 לשישי, ושבועיים לאחר 28 לשישי עוד שיעור של שעתיים. זה הכל. זה גם יהיה ביום שישי מ-9 עד 11. ככה זה יצא שלמעשה ערכתי את המנוי בעצם בשבועיים, כן? כי זה יצא עוד שיעור של שעתיים כל יום שישי. 2 שיעורים של שעתיים של יום שישי, זה הכל. זה כל הסיפור.
בסדר גמור.
בסדר, אז ליום שישי הקרוב זה חצי שעה, ולאחר זה 128 לשישי, ביום שישי שלאחר 28 לשישי זה שעתיים, ואחרי זה שבועיים לאחר 28 לשישי עוד שעתיים. כך זה יצא בדיוק שיעור של שעתיים, 128 לשישי. 2 שיעורים של שעתיים, 128 לשישי ביום שישי. ועוד חצי שעה ליום שישי הקרוב, זה הכל. אוקיי?
אין שום בעיה, בסדר.
בסדר?
בסדר גמור.
בסדר, טוב, תודה לך.
תודה לך, אוקיי.
שלום. So the area of the blue lens equals to 2 times the area of the circular segment NM. Why? Because those 2 circular segments, they are identical. The lower circular segment is a mirror image of the upper circular segment, the green circular segment. So the area of the blue lens will be equal to 2 times the area of this circular segment NM. And repeat again, the area of the blue lens equals to 2 times the area of this circular segment NM. So we have to find out the area of this circular segment NM. The green circular segment NM, the area of the green circular segment NM, this circular segment, it will be equal to So the area of circular segment NM, this circular segment, it will be equal to the area of sector NOM this is sector NOM. Note that the angle between the legs of the sector NOM equals to 2 theta minus the area of triangle NOM. Okay, so the area of sector NOM, actually we know that sector NOM is a quarter circle. And the area of any quarter circle equals to the area of the circle, that is pi r square, and r equals to a, so it is pi a square over 4. This is the area of sector NOM, that is actually a quarter circle. A equals to 5 is actually, we know that the radius of each semicircle equals to 5 units, so A equals to 5, so it is actually pi a square is pi A equals to 5, so it is pi times 5 square over 4 minus the area of the right triangle. Here A equals to 5, so the area of the right triangle AOM, it is equals to 5 times 5 over 2. This is the area of the right triangle, triangle NOM. So in conclusion, the area of sector NOM equals to 5 square is 25, so it is 25 pi over 4 minus 25. So this is the area of sector NM, and now we have to multiply the area of sector NM by 2 in order to find out the area of the blue lens, because the area of the blue lens equals to 2 times the area of sector NM. So we'll multiply it by 2 and we'll get the area of the blue lens. So the area of the blue lens equals to 2 times the area of sector NM, and the area of sector NM equals to 25 pi over 4 minus 25. So if we multiply the area of sector NM by 2, we get the area of the blue lens. So here, just 25 over 2. Repeat again that the area of the blue lens equals to 2 times the area of circular segment NM, and the area of circular segment NM equals to 25 pi over 4 minus 25 over 2. So the area of the blue lens equals to, here we will divide both the numerator and the denominator by 2. 2 over 2 is 1, so in the numerator we have 25 pi, and 4 over 2 is 2, so in total this expression equals to 25 pi over 2, and here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled and we left only with 25. So in conclusion, the area of the blue lens will be equal to 25 over 2 is 12.5 pi minus 25 square units. Okay, so we finished with the blue lens, found out the area of the blue lens. Is equal to 12.5 pi minus 25 square units. In the next step, we will find out the area of the big lens. Okay, so we'll find out the area of the big lens, and actually the area of the big lens was created by the intersection of the quarter circle with this semicircle. Okay, so here we will join the two centers M and O of the quarter circle and the semicircle by a straight line. Here we draw the radius that is tangent to the semicircle at point L. OL is the radius of the quarter circle that is equal to 10 units. Here, from the center of the semicircle, we will draw here a tangent to the quarter circle. So here we know that tangent ML is tangent to this quarter circle, and we have the radius OL of the quarter circle that is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent ML, with this quarter circle. And whenever we have a radius that is drawn to the point of tendency, then tangent ML will be perpendicular to the radius LO. So if ML is perpendicular to LO, it means that this angle MLO, will be equal to 90 degrees. So ML is the radius of the semicircle because it starts from the center of the semicircle and then ends at point L, that is a point on the semicircle itself. That is to say, it is equal to 5 units because the radius of the semicircle equals to 5 units. Here, line segment MN, we know that point N is the center of the semicircle and point N is a point on the semicircle itself. That is to say, it is the radius of the semicircle that is equal to 5 units. But MN, here, we have MN that is actually also tangent to the semicircle at point M. Point N is the point of tendency of tangent MN with this quarter circle. And we have the radius ON that is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent MN with this quarter circle. And whenever we have a radius that is drawn to the point of tendency, then tangent MN will be perpendicular to the radius NO. So if MN is perpendicular to NO, it means that this angle equals to 90 degrees. So actually, those two right triangles can point to each other according to side rule. Here, side NO equals to side OL equals to 10 units. Those two sides are both equal to 5 units, therefore they are equal to each other. And we also have side OM, that is a common side that belongs to both triangles. So if we define angle NOM as theta, then angle MOL will be also equal to theta because of the fact that those two angles, they are equal to each other. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so therefore those two angles are equal to each other, so if this angle equals to theta, then this angle must be also equal to theta. Here we join points N and M together by a straight line. By joining points N and M together by a straight line, we divided the big length, this big length, into two parts. We have the upper circular segment NN and we have the lower circular segment NL. We will find out the area of each part, then we will add the two areas together, and this will be the area of the big length. Okay, so we'll start if in this step we'll find out the area of the upper circular segment NL, the green shade. So the area of the upper circular segment NL it will be equal to the area of this the upper circular segment NL, the green circular segment NL, and M and L, the green circular segment NL of the big length it will be equal to the area of sector NOL minus the area of triangle NOL. So it will be equal to the area of sector NOL this is sector NOL minus the area of triangle NOL. Again, if you subtract from the area of sector NOL the area of triangle NOL, you will get exactly the area of circular segment NL. So we actually know that the angle between the legs of sector NOL, it is equal to 2 pi. So the area of sector NOL will be equal to the area of the circle here, and MO equals to 10 units. So the radius of the quarter circle equals to 10. So the radius of the circle itself is pi r square. It is pi times 10 square times the ratio between the angle between the legs of the sector NOL over, that is 2 theta, over 2 pi, that is 360 degrees in terms of degrees. So it is 2 pi. So in total, in conclusion, the area of sector NOL equals to 2 theta over 2 pi times pi 10 square. We have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So in conclusion, we found out that the area of sector NOL equals to 10 squared, that is 100, times theta. Now we have to subtract from the area of the sector the area of triangle NOL. The area of triangle NOL equals to the multiplication of the two sides by each other, that is 10 times 10 over sinus the angle between the two sides, that is 2 theta over 2. So in conclusion, the area of circular segment NL equals to 100 times theta minus 10 times 10 is 100, and 100 over 2 is 50, so it is 50 times sinus 2 theta. Okay. In the next step, we'll find out the value of theta and the value of sinus theta by analyzing the triangle, the right triangle NOL that consists angle theta. Okay. So I will draw the right triangle NOL in a new page, and we will derive from this right triangle NOM the value of theta and the value of sinus 2 theta. So we have here the right triangle NOM, and then O and M equals to 90 degrees. And then NOM equals to theta. So in the right triangle NOM, in this right triangle NOM, tangent theta equals to NM over NO. Here NM equals to 5, NO equals to 10, so in conclusion tangent theta equals to 5 over 10, that is 1/2, that is also 0.5. So in conclusion we found out that tangent theta equals to 0.5, but we don't need the value of tangent theta, but we do need the value of theta itself. So in order to get the value of theta itself, we'll operate the opposite function of tangents of the result, and this operation will give us the value of theta itself. So we'll operate the value, the opposite function of tangents, that is tangents minus 1, on the result, that is 0.5, and this will give us the value of angle theta itself. This is the angle that we are looking for, so we found out the value of angle theta. It is equal to tangents minus 1, that is the opposite function of tangents, of 0.5. In the next step we will find out the value of sinus 2 theta. Actually we know that sinus 2 theta equals to 2 sine theta cosine theta, so I will draw the right triangle NON again here. First of all, we will find out the length of the hypotenuse OM by implementing the Pythagoras theorem on the right triangle NOM. So in the right triangle NOM, by PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OM, and the square of the hypotenuse is OM squared. And it is equal to the sum of the squares of the perpendiculars, that is to say it is equal to 10 squared, that is 100, plus 5 squared, that is 25. So in conclusion, we found out that OM squared equals to 100 plus 25 is 125. Here we take a root out of this equation and we find out that OM equals to the square root of 125, and 125 is 25 times 5, so we substitute 125 by 25 times 5. We take a root out of this equation and we find out that the root of 25 is 5, so inside the root we left only with 5. So in conclusion, the hypotenuse OM equals to 5 times square root of 5. So the value of sinus 2 theta it is equal to 2 sine theta cosine theta. So sinus 2 theta equals to 2 times sinus theta, but from triangle NOM we can see that sinus theta equals to NM over MO. So sinus theta equals to NM, that is 5, over MO, that is 5 times square root of 5. So in conclusion, sinus theta equals to 5 over 5 times square root of 5 times cosine theta. And cosine theta equals to NO over OM. NO equals to 10, and OM, the hypotenuse, equals to 5 times square root of 5. So in conclusion, we found out that sinus 2 theta equals to this expression. Here we have 5 in the numerator and 5 in the denominator, so 5 will get cancelled. So here in the numerator we have 2 times 10 over square root of 5 times square root of 5 is 5 times 5. So here ten over 5 is 2, and 2 times 2 is 4. In the denominator we left only with 5. So in conclusion, we found out that sinus 2 theta equals to 4/5, while tangents minus 1, while theta itself equals to tangents minus 1 of 0.5. Theta itself equals to tangents minus 1, that is the opposite function of tangents, of 0.5. Okay? So we have already found out that the area of the upper circular segment and L of the big lens is equal to 100 times theta minus 50 times sinus 2 theta. Now we'll substitute theta we substitute theta by tan x minus 1 of 0.5, and we'll substitute sinus 2 theta by 4/5. We'll do it now, and we'll get that the area of the upper circular segment of the big lens is actually equals to 100 times theta, and theta equals to tan x minus 1 of 0.5 minus 50 times sinus 2 theta, and sinus 2 theta equals to 4/5. Okay, so I actually found out that the area of the upper circular segment of the big lens and L, it is equal to 100 times tan x minus 1 of 0.5. Here we have this expression, 50 over 5 is 10, and 10 times 4 is 40. So in conclusion, the area of the upper circular segment of the big lens equals to 100 times tan x minus 1 of 0.5 minus 40 square units. So in the next step, we'll find out the area of the lower circular segment. Here we found out the area of this lower circular segment, so I'll draw again the drawing here. Here you have to find out, this is N O M L so this angle equals to 90 degrees. It is a right angle. And this angle also equals to 90 degrees. It is also a right angle. We join the two centers together by a straight line. This angle equals to theta. This angle also equals to theta. NO is the radius of the quarter circle that is equal to 10 units. OL also is the radius of the quarter circle that is equal to 10 units, because of the fact that it starts from the center of the quarter circle and ends at point L, that is the point of the quarter circle itself. This is exactly the definition of a radius. So OL is the radius of the quarter circle that is equal to 10 units. Okay, now our mission is to find out the area of the lower circular segment NL. In order to find out the area of the lower circular segment NL, we actually first of all have to find out the size of angle NML. So what is the size of angle NML? First of all, because of the fact that triangle MNO is a right triangle, this angle equals to 90 degrees. This angle equals to 90 degrees, that is pi over 2 in terms of radians. So this angle must be equal to pi over 2 minus theta. And this angle equals to theta, this angle equals to 90 degrees, so this angle must be also equal to pi over 2 minus theta. So we will add the two angles together in order to find out the size of angle NML. So the size of angle NML will be equal to pi over 2 minus theta plus pi over 2 minus theta. So pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the size of this angle NMN, it is equal to pi minus 2 theta. Okay, so what is the area of the lower circular segment NN? The area of the lower circular segment NN will be equal to the area of sector NML So the area of the lower circular segment of the big length NN will be equal to the area of sector NML. This is sector NML minus the area of triangle NML. This is triangle NML. And this angle equals to pi minus 2 theta in terms of radians, of course. So what is the area of sector NML? The area of sector NML will be equals to, here MN equals to 5, NM also equals to 5. It is they are the radii of the semicircle, NM equals to 5 and NN equals to 5. As you can see from this drawing, they are both equals to 5 units. So the area of sector MNL will be equal to the area of the circle, that is pi r squared, and r equals to 5, so it is pi times 5 squared, 5 squared is 25. So the area of the circle is 25 pi times the angle between the legs of sector NML is pi minus 2 theta over 2 pi, that is 360 degrees in terms of degrees. 2 pi radians is 260 degrees. So here, in conclusion, we found out that the area of sector MNL equals to 25 pi times pi minus 2 theta over 2 pi. Here we have pi in the numerator and pi in the denominator, so pi will get cancelled. Here we open the brackets and we get that the area of sector M and L will be equal to 25 pi over 2 minus 25 2 theta over 2. So the area of sector NML, in conclusion, it will be equal to 25 over 2 is 12.5. So this expression equals to, in total, to 12.5 pi. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So this expression in total equals to 25 theta. Okay, so in conclusion, the area of sector NML equals to 12.5 pi minus 25 theta. We find out the area of triangle MNL. The area of triangle NML will be equal to the multiplication of the two sides together, that is to say, it will be equal to 5 times 5 times sinus the angle between the two sides, that is pi minus 2 theta over 2. So, in conclusion, we found out that the area of the lower sector of the big lens, the lower circular segment NL of the big lens it is equal to 12.5 pi minus 25 theta. Here 5 times 5 is 25. So it is 25 over 2 times sinus pi minus 2 theta equals to sinus 2 theta times sinus 2 theta. So in conclusion, the area of the lower circular segment of the big lens equals to this expression, but we have already found out that sinus 2 theta equals to 4/5, so we can substitute sinus 2 theta by 4/5, so we'll do it now and we'll get that the area of the lower circular segment of the big lens, it will be equal to 12.5 pi minus 25 theta minus 25 over 2, and sinus 2 theta equals to 4/5. So we'll substitute sinus 2 theta by 4/5. So in conclusion, the area of the lower circular segment of the big lens will be equal to 12.5 pi minus 25 theta, and here we have 25 over 5 is 5, and 5 times 4 is 20, and 20 over 2 is 10. So in conclusion, this expression equals to 10, so here it is minus 10. So in conclusion, we found out that the area of the lower circular segment equals to 25 pi, 12.5 pi minus 25 theta minus 10. And we have already found out that the area of the upper circular segment of the big lens, it is equal to 100 times tangents minus 1 of 0.5 minus 40. This is the area of the upper circular segment of the big lens. Now, in the next step, we will add together the two circular segments, and in this way, we will get actually the area of the big lens. The sum of the areas of the two circular segments will be equal to the area of the big lens. So here the area of the big lens is equal to the area of the upper circular segment plus the area of the lower circular segment. Okay? So the area of the big lens equals to the area of the upper circular segment equals to 100 times tangent minus 1 of 0.5 minus 40 and the area of the lower circular segment equals to 12.5 pi minus 10 minus 25 theta, but we have already found out that theta equals to tangent minus 1 of 0.5. So substitute theta by tangent minus 1 of 0.5, and in conclusion we found out that the area of the big lens equals to 100 times tangent minus 1 of 0.5 minus 25 times tangent minus 1 of 0.5 equals to 75 times tangent minus 1 of 0.5 okay, and we have here minus 40 minus 10 is minus 50, and we also have here plus 12.5 pi. So this is the area of the big lens. In the next step we subtract from the area of the big lens the area of the blue lens, and this way we get the area of the green of the orange shape. Okay, the area of the orange shape equals to the area of the big lens minus the area of the blue lens. Okay, so the area of the orange shape equals to the area of the big lens, and we have already found out that the area of the big lens equals to 75 times tangent minus 1 of 0.5 minus 50 plus 12.5 pi, and we have to subtract from the area of the big lens the area of the blue lens, and we have already found out that the area of the blue lens equals to 12.5 pi minus 25. So here we will open the brackets, and we will get that the area of the orange shape equals to the area of the orange shape equals to 75 times tangent minus 1 of 0.5 minus 50 plus 12.5 pi. We will open the brackets here, so here it will be minus 12.5 pi. And minus is plus, so it is minus 25, it is plus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5. Here we have 12.5 pi minus 12.5 pi is 0, so those two expressions will get cancelled. And we have 25 minus 50 is minus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. We actually know that tangents minus 1 of 0.5 is actually equals to 0.46. So we have to multiply 75 by tangents minus 1 of 0.5, and we have to subtract from it 25. So the area of the orange shape will be equal to 75, and tangents minus 1 of 0.5 is 0.46 minus 25. So in conclusion, we found out that the area of the orange shape is equal to 75 times times 0.46 is 34.77 minus 25. And 34.77 minus 25 is 9.77. So in conclusion, we found out that the area of the orange shape equals to 9.77 square units. Okay. So in both methods we arrive to the same answer, that the area of the orange shape, the area of this orange shape, it is equal to 9.77 square units. So in the next step I will summarize the lecture. We'll start with the first method. So in the drawing, we have square ABCD. We know that one side of square ABCD equals to 10 units. Inside square ABCD, we have two semicircles that intersect with each other at 90 degrees. Here, semicircle CPD and semicircle APD, and they create actually the blue lens, and a lens is a common area that was created by the two semicircles. And we also have a quarter circle. This quarter circle ABQD intersects with this semicircle CPD and create this big lens. And our mission is to find out the area of the orange shape. So it is very easy to see from the drawing that the area of this orange shape equals to the area of the big lens minus the area of the blue lens. So we'll find the area of the blue lens, we'll find out the area of the big lens, and we'll subtract the area of the blue lens from the area of the big lens, and this way we get the area of the orange shape. But first of all, I presented to you two terms. The first term is the area of sector, the green sector. The area of this green sector equals to the area of the circle that is pi r square. R is the radius of the circle times the amount of percentage that the sector occupies from the whole circle. This percentage will be given to us by dividing the angle between the legs of the sector over 2 theta radians. And 2 theta radians is 360 degrees. In terms of degrees, it is 360 degrees. So you can see it also as theta over 360 degrees. It is exactly the same thing if you divide theta that you have in terms of degrees by 360 degrees. Okay, here theta is in terms of radians, so 2 pi is equal to 360 degrees. In terms of degrees, it is equal to 360 degrees. So the ratio between the size of the angle between the legs of this sector over 2 pi, it is the amount of percentage of the sector occupies from the whole circle times the area of the circle will give us exactly the area of this sector. So theta over 2 pi times pi r square is the area of a sector. That is to say, it is the area between the legs of the angle between the legs of the sector over 2 pi radians, that is equal to 360 degrees in terms of degrees, times the area of the circle, that is pi r square. So this is the area of a sector. Then I presented to you the theorem of circular segment. The green shape is a circular segment, and the area of the circular segment, it will be equal to the area of sector A or B minus the area of triangle A or B. If you subtract the area of triangle A or B from the area of sector A or B, you'll get exactly the area of this green circular segment AB. Again, the area of sector A or B minus the area of triangle A or B will give us exactly the area of circular segment AB. This is the green shape. Okay. Then, actually, I repeat again that the area of the orange shape, this orange shape equals to the area of the big lens minus the area of the blue lens. Again, the area of the orange shape equals to the area of the big lens minus the area of the blue lens. So we'll find the area of we'll find out the area of the orange shape in two different methods. We'll start with the first method. In the first method, we will find out a general formula for the area of any lens, and we will use the new formula in order to find out the area of the blue lens. Then we'll use the same formula in order to find out the area of the big lens, and we'll subtract the two areas from each other, and this will give us the area of this orange shape QPD. Okay, this will be the first method, while according to the second method, we will directly calculate the area of the big lens, we calculate the area of the blue lens, and we'll subtract the two areas from each other. In this way, we'll get the area of the orange shape DPQ. The advantage in the first method is that we will create a formula. In the new formula that we will create, that it will be for the area of any lens. The only missing variables that will be in this new formula will be only the radii of the two shapes that intersect with each other. While according to the second method, we will have to find out the area of a triangle that is contained by the sector. So it will be a little longer way. Okay, so we start with the first method. In the first method, we'll create a general formula for the area of any lens. So here we have two semicircles that intersect with each other, and in the intersection point they create this lens, and our mission was to find out the common area of the two semicircles that is actually defined as the lens. So this lens, it is actually the common area of the two semicircles. But because of the fact that those two semicircles can be any semicircles, could be any semicircles, we don't have the radii of those semicircles, two semicircles. The radii of the fourth semicircle equals to 8. It could be any number, any positive number, and the radii of the other circle will be equal to b units. That it also could be any positive number. For that reason, we can use the new formula in order to find out the area of the blue lens and the area of the big lens. So we start with the mission. So we have to find out the area of this lens. First of all, we find out the area of the upper circular segment, then we find out the area of the lower orange circular segment. We'll add the two areas together, and this will be the area of this lens. Because this lens composed of two circular segments, and the sum of the areas of those two circular segments will be equal to the area of the lens. So first of all, we'll find out the area of the orange circular segment, the upper circular segment. What is the area of the upper circular segment NM? It will be equal to the area of sector NOM minus the area of triangle NOM. Here you can see that the area of the upper circular segment NM, it is equal to the area of sector NOM minus the area of triangle NOM. If you subtract the area of triangle NOM from the area of sector NOM, it is very easy to see that you will get the area of circular segment NM. Okay, so first of all, we have to find out the area of sector NOM. Here, the angle between its legs is 2 theta. Therefore, the area of sector NOM equals to the angle between its legs over 2 pi times the area of the circle, that is pi r squared, and r equals to a, so it is pi a squared. So in total, the area of the of sector NOM equals to theta times a squared minus the area of triangle NOM, and I already mentioned that we don't have to find out the area of the triangle at all, and this is the advantage of the first method. For that reason, it will be shorter than the second method. There we will have to find out the area of the triangle. Okay, so in the next step we will find out the area of the lower circular segment, the lower orange circular segment NM. So the area of the lower circular segment NM equals to the area of sector NNM as the area of triangle NNM. In conclusion, the area of sector NLM equals to pi b squared over 2 minus theta b squared. And the area of the lens, that could be any lens, is the sum of the areas of the two circular segments, the upper circular segment and the lower circular segment. In each circular segment we have to deduct the area of the triangle. So in total the area of the two circular segments equals to this expression, and we have to subtract from the area of the two sectors the sum of the areas of the two triangles. We combine the two triangles together. In this way we created this quadrilateral NLOM. We joined points N and O together. We joined points N, L and O together. In this way we created two right triangles, the green right triangle and the orange right triangle. The area of each right triangle equals to A times B over 2. And the sum of the areas of the two triangles is A times B. So here the sum of those two the areas of the two triangles is A times B, so we'll subtract AB from this expression. In this way, we'll get the area of this sector that could be any sector. So we actually found out that the general formula for the area of any length equals to this expression. This is tangent minus 1 of b over 8 times a square minus b square plus pi b square over 2 minus ab. And we found out the area of the big length by we know that the radius of the quarter circle is 10, so A equals to 10, and the radius of the semicircle is 5, so B equals to 5. We put the values of A and B inside this formula, and we found out that the area of the big length equals to this expression. And then we found out the area of the blue length. The area of the blue length equals to this expression. And as I already mentioned, the area of the orange shape equals to the area of the big length minus the area of the small length. So we subtracted the two areas from each other, and in conclusion we found out that the area of the orange shape equals to 9.77 square units. We finished with the first method. Then I presented to you how to find out the area of the orange shape according to the second method. In the second method, we found directly the area of the blue shape, and we found directly the area of the blue length, we found directly the area of the big length, and we subtracted one from each other, and we actually found out that the area of the big length according to the second method, it is equal to 9.77 square units. So in both methods we actually arrived to the same result, that the area of this blue length it is equal to 9.77 square units. I repeat again that the area of this blue length, the area of this orange shape, it is equal to 9.77 square units, and in general it is equal to the area of the big length minus the area of the blue length. It is equal to the area of the orange shape, and the area of the orange shape in both methods we found out that it is equal to 9.77 square units. Okay, thank you very much.